All right, good afternoon, everybody. We're going to go ahead and start into our section 2 notes, and our learning goal is going to be based on 3.02 on your student tracking sheet, which is I can balance chemical equations. Now, when talking about chemical equations, one of the big things that we want to look at is what's called the law of conservation of mass. This rule basically says that I can't completely destroy or create matter from just nowhere. Even in a chemical reaction, all of those materials start off in a certain location. They start off as a part of it. They just look different on the other side. So we're going to explore this and see how we can actually apply this to our chemical reactions in general. So here we go. Now, why do we need to balance the equations? If we look at the equation given to us, we have sodium plus chlorine gas yields sodium chloride. Now, if we have these elements as they are, we don't have the same amount on both sides. And we just said in our law of conservation of matter that we need to have the same amount of each element on both sides at the beginning and at the end. So, although we have sodium being okay, chlorine is not. What we're going to do in order to fix this is we have a little saying that we're going to use. Now, it's slightly different than the one that I used in class. But this one, we're just going to say, mice never have olives. Sounds weird, sounds very, very strange, but we're going to use this to give priority to how we're going to move through our equations. So we're going to start off with our metals, then to our nonmetals, our hydrogen, then oxygen is always last. Don't ever, ever, ever start with oxygen. Make sure you save it for last. If you start with it, you'll end up with a big headache, and we don't want that. So, now, to keep track of the atoms that we're going to use when balancing equations, we're going to write them underneath the equation itself. And we'll just keep it going. So, like we had here for sodium chloride, we're using the same example. I had 2 sodium atoms plus 1 chlorine gas are going to yield me or give me 2 sodium chloride atoms. When we balance the equation, we can't change any subscripts. We only add coefficients like we did in our counting atoms activity to show that we have more than one of those molecules present. So, like what we did here. Now, this may seem kind of weird and it's going to get frustrating for some. We may have to go through the equation more than once. We may have been okay before, but now we're making a change to it, and so it's going to adjust some things. So just bear with me, and we're going to work through the process and make sure that you understand. So, here's our practice. We have H2, which is hydrogen gas, plus oxygen is going to give me water molecule. But we need to see how much of each, because right now, although our hydrogen are okay, we have 2 on both sides, we don't have 2 in the oxygen category on the right side. All right, so first thing we do is we go through our metals. Looking at this, we have no metals. Remember, we said our metals are going to be to the left side, almost the entire left side of the periodic table. So that one's gone. Now, what about our nonmetals? Well, outside of hydrogen and oxygen, we don't have any other nonmetals to work with. So moving on to hydrogen, which we just said seems to be okay because we have 2 on the left as well as 2 on the right. Now, I ran into a slight issue though because my oxygen are imbalanced. So what I did is, since I have 2 oxygen on the left, I have to have 2 on the right. I'm going to add another water molecule to the part. Now, you may be asking, why is it that you're adding H2O when all you need is just the oxygen? Well, the oxygen is actually bonded to the hydrogen. So I have to add the whole piece. I can't just chop it up into parts. So this makes me have to adjust my hydrogen back on the other side. This is what I talked about once you go through, you may have to come back and adjust. And it's perfectly fine. Everything is still okay. Now as I look at this, I have 4 hydrogen on each side and I have 2 oxygen on each side. This gives me a balanced equation. My last step is just to write in the coefficients. The coefficients will be based on how many times I've written it down. So I have 2 times that I wrote hydrogen gas, and I have 2 times that I wrote water. So I'm going to add the coefficients accordingly. Give me 1 second. We'll be right back to finish this up. Now that you've had a second to sort of think about it and wrap your head around what's going on, we want to go back and do a little bit more practice. So now we have a much larger equation. We see more parts to it, but we're still going to go through the same process. So starting off, we have our metals. Now, metals are going to be found again to the left side of the equation. left side of the periodic table. So we have copper, which is a type of metal, and we have silver, which is a type of metal. We need to make sure we have the same amount on both sides. According to what I have here, I have 1 copper and I have 1 silver. On the other side, I'm running into the same thing. So our metals at the moment are okay. Now, what about our non-metals? Well, since we said we save oxygen for last, let's go to our nitrogen. I currently have 1 nitrogen here, and if we go back to our counting atoms, since I have this 2 outside, I have 2 nitrogen on this side. How will I fix it? Well, all I'm going to do is add another silver nitrate, AgNO3. This now gives me my 2 nitrogen, which I needed. Okay? Now, as we keep going down, we're going to look now for hydrogens. No hydrogens present. So, next move, onto oxygen. I have 6 oxygen, because I have 3 plus 3, and I have 6 oxygen on this side. Oh wow, our oxygen are good. Am I done? I have one slight issue. My one slight issue is I have 2 silver now on this side and only 1 over here. How do I fix it? Remember, our rule is we fix it by adding to the other side. So I'm going to add another silver. Now, is everything done? I can go back through and check. Everything looks like it's supposed to. My last thing to do is just write the coefficients. Now, in chemical reactions, if the coefficient is 1, we don't have to write it. So for this first one, I'm going to leave it, well, I usually leave it blank, but for this one, I'm going to show you that it's 1. Okay, next one, we've written it 2 times, so our coefficient will be 2. Then we'll have 1 and 2. And our equation is balanced. This is what we're going to practice tomorrow in class. Make sure you take your notes, finish everything that we're going to do. That way you'll be able to participate accurately in class. Have a great evening, and I will see you again tomorrow.